Hi, Algebra 2ers. Today we are taking our own notes and using some notes out of the note packet. So you might want to locate your note packet right now. There wasn't much in there, but this is one of the days that is. So we're going to start on our own paper, and then we'll move over into the note packet. So as a reminder of what we did yesterday, we were talking about the quadratic formula, which is the x equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So the part that's underneath the radical, excuse me, that is referred to as the discriminant. All right, so this piece, I'm going to grab a little red pen right here. That part, that is called the discriminant. So specifically the b squared minus 4ac part. So you'll notice that the title on today's notes is called the discriminant, and then the nature of the roots, which sounds kind of fancy, but it's not that fancy, right? What we're going to look at is, depending on what kind of value you get underneath the radical, that tells you what type of roots you'll end up with. So the value of the discriminant determines what I'm going to call the nature of the roots, which is synonymous with answers of the quadratic equation. So we talked about it in yesterday's notes, that sometimes the answers came out real, and I do refer to that as pretty, even though that's not a math term. Sometimes they're a little messier, so irrational. Sometimes they came out imaginary, and so on. So what I'd like to look at is that note sheet that's in your note packet, so that we can kind of see all the different cases and have a nice little list of rules for ourselves. So on that sheet, what I want you to look at is this little Venn diagram-y looking thing. We talked about the fact that all numbers fall into the category of, complex numbers. And a complex number is the whole a plus bi thing. So the a part of it, that's all the real numbers. The bi, that's all the imaginary numbers. And then within real numbers, you can break it down further into different categories. The two categories that we're going to focus on are, do the numbers come out rational, which is quote unquote like the pretty ones, so like 5 or a third, something like that, or irrational, which is when you're left with a radical, or you might remember pi, something like that. That's an irrational number as well. So we talked just a moment ago, quadratic formula. You can throw that on here as well. Plus or minus the whole b squared minus 4ac all over 2a, specifically the b squared minus 4ac piece of it. That's the discriminant. So that's what we're going to focus on here. Now, something to keep in mind, you're going to notice that some of the work is done for us. We're going to take advantage of that to help speed through this. So the first example, you're given the equation y equals 2x squared plus 3x minus 2. And then over here, it's already been set equal to 0 and solved for the roots using the quadratic formula. Because if you look, here's like the a, the b, the c, they've all been plugged in over here. So thank you very much. And what I want to look at is within that work, what is the value of the discriminant? So specifically, the discriminant is that value underneath the radical. So once they got it down to one value, it just came out to be 25. So the b squared minus 4ac part came out to be 25. All right, over here, when it says, what was the nature of the roots? What are the number of unique solutions? Well, the actual roots themselves came out to be a half and came out to be -2. Those are nice real numbers, right? They are absolutely rational because they're pretty fractions. There's no radicals left in them. And then as for the unique solutions, you get, oh, oops, I just realized I'm writing in the wrong spot. So the nature, whoops, real, rational, and then there was 2 unique solutions. So I got white out. I'll fix that. On your paper, you can cross it out. You can erase it, whatever you got going on there. Right. And so because there's two unique solutions, sometimes we'll classify that as the roots as being unequal, literally meaning there's one here at -2, there's one here at a +1/2. They are two different values. All right. When we look at the next one, b squared minus 4ac in all of their beautiful work here. So they looked at this equation, came out to be 0. So when it came out as 0, what kind of answers did they get? Well, look at their work. They got 1/3 and they got 1/3. Those are two real numbers. So under nature of the roots, we're going to write real. They're rational. And then when we think about it as terms of unique solutions, well, that's the same answer twice. So there's only one unique solution. And so you could say that these are equal roots because you're always going to get two answers. Do they come out the same or do they come out different? So here they were equal. Last time they were unequal. All right, cool. Next case, you've got this equation to work with. All the beautiful work has been done for us. So what was the discriminant? Well, the b squared minus 4ac this time came out to be 13 right there. Okay, well, what kind of answers did they end up with? Well, they came up with answers that these are real numbers because 13 underneath the radical would just give me a decimal. So these are real, but they're irrational. All right, and then in terms of equal or unequal, these would be completely different. One's plus radical 13, one's minus. All right, and when you look at the graph, you can see it's hitting in two different points. Those are unequal roots. And so number of unique solutions would be 2. Something I forgot to point out on the last one, like when there's one unique solution, look, it's only hitting the x-axis in one spot. So you can visually see it, and then you can also calculate it that way. All right, last case. The discriminant here, the b squared minus 4ac, comes out to be -23 underneath there. So they got -23. All right. What do you know about the roots? Well, look at those roots. The one thing that stands out to me is the I in there. They are imaginary, which should make sense because come over here. It doesn't hit the x-axis. So when we say that they're imaginary, in terms of the number of unique solutions, we don't even really need to quantify that. You could say that there's two non-real solutions, but basically it's the idea that there are no x-intercepts at all right? No real x-intercepts, right? So it does not hit the x-axis. So what are these four cases really showing us? Well, let's go back up. Here, 25, the reason that that was special is because you could take the square root of it. So this was a perfect square. That's what was special about that 25. So there's case number one. When it's a perfect square, you're going to be able to take the square root. You're going to get these beautiful answers. So real, rational, and unequal because you get two different answers. All right, in the second case, 0 is its own special case unto itself. When it comes out to be 0, yeah, you can take the square root of it, but more importantly, you end up with the same answer twice. So it comes out real, rational, but you get two equal answers. All right, the third case, nothing really super important here other than the fact that it's positive and it's not a perfect square, which meant we couldn't simplify it completely. So not a perfect square is actually how I'm going to categorize it. And then this way, it forced the answers to be irrational because we couldn't fully simplify. And then the last case, the second it came out negative underneath a radical, that's what forced the imaginary part to happen. And once you say the roots are imaginary, I don't really have to answer the rest of the questions there. So keep this little note sheet next to you as we go back to our own paper, and we can use this as a nice reference here. All right. Let me flip my page on over. I'm coming back to my note sheet. So we're going to do some practice with this. And if you need to, maybe write yourself a note to look in the notes packet for the rest of the notes that goes with this. That might be helpful. All right. So for each of these, what I want you to do is part A, determine the discriminant. And then part B, describe the nature of the roots. So what we're looking at is we don't really need to fully figure out the answers. Just the discriminant will tell us what kind of answers that we get, right? And then part C, once we do that, part C, we're going to solve for x. And so your options for that, factor, complete the square, or quadratic formula. Okay, let's try it. So for number 1, we've got x squared minus 3x minus 10 equals 0. What I want to know is, what is the discriminant? So just like you would for a quadratic formula question, I think it's nice to start by writing this off to the side. So a is 1, b is -3, c is -10. All right. So b squared minus 4ac is going to be equal to -3 squared minus 4 times a is 1 times c is -10. So I get 9, and then that's going to turn into plus 40. So we get 49. So that's the first part. That's the answer to part A. That is the discriminant. Part B now says describe the nature of the roots. Well, what I care about here is that this was a perfect square. So if it was a perfect square, I'm going to be able to take the square root. I'm not going to have a radical left. So that means that was case 1, that it's real, or that they are real. They're going to be rational, and that they'll come out different, because one will be plus the square root of 49, the other one will be minus the square root of 49, or radical 49. Oh yeah, I said that right. Square root of 49. All right, last part. If they're real and rational, that means that you can factor it. So part C is kind of up to you. You can factor, you could complete the square, you can do quadratic formula, but that's telling you right there that it is factorable. So now if we try to factor this guy, x squared minus 3x minus 10. What adds to this and multiplies to that? Well, 10 doesn't have a ton of factors, so 5 and 2 will do it. We're going to minus 5 plus 2. This will give us -2 and then +5. And those answers are absolutely real, rational, and unequal. They're 2 distinct values. All right, that's it. Let's try a second one. So I'm going to slide on up, same directions here. And so I'm going to give you 4x squared plus 9 equals 12x. All right, if we take the same approach here, we're going to calculate each piece. So part A, we're going to calculate the discriminant. All right, well, let's see. I'd have to rearrange this guy first. This is really 4x squared minus 12x plus 9 equals 0. Make sure it's in that standard form. So then A is 4, B is -12, C is 9. All right, B squared minus 4AC is going to be -12 squared minus 4 times 9. You can absolutely grab your calculator here. -12 squared, I know you guys know that one. So that's going to be 144. And then 4 times 4 times 9, right here, that's also 144. So when we take the difference, that comes out to be 0. So that's the answer to part A, that the discriminant is 0. Part B, well, what kind of roots are you going to get? Well, if I'm taking the square root of 0, it comes out as 0. It's going to come out nice. So first of all, it's going to be real. Nice values, meaning no radical left, are rational. The only difference is that they're going to come out equal to each other. And that's because one answer will be plus 0. The other answer will be -0. You'll get the same thing twice. So that's the equal piece of it. All right. For part C, because we know they're real and rational, again, it's factorable. If you want to factor it, go for it. You can probably tell that this would be a great one for a little slip slide divide. If you're thinking, I don't want to do that, you can always use the quadratic formula. So if I take this and I don't feel like slip slide divide, then your option would be to say, okay, let me run the rest of the quadratic formula. You've already done half the work already. It would be x equals negative b, so 12, plus or minus the square root of the discriminant, you already did that work, 0, all over 2 times a. Look how nice that is, because half the work's done. So 12 plus or minus 0 just becomes 0, and then all over 8. So the answer that I would end up with here would reduce down to 3/2. So that would be our one answer that we'd get, because it's real, rational, and equal. So you would get 3/2 twice, but what that means is that this is called a double root, and that particular parabola, if we set it equal to y, would just hit the axis in one spot. All right, we got one last question to try, and then we will call it quits with these notes. So example 3, we got x squared minus 6x plus 2 equals 0. All right, first step, discriminant. So a is 1, b is -6, c is 2. So -6 squared minus 4 times 1 times 2 would give me 36 minus 8, which is 28. Since that's not a perfect square, what that should signify to me is that for part B, when we talk about the nature of the roots, if I try to take a square root of 28, it's not going to simplify. At least not going to simplify completely, I should say it that way. Which means that we're going to get real roots, but they're going to be irrational. And therefore, they'll come out unequal when we do plus radical 28 versus minus radical 28. Well, you can hear Teddy. All right, last one, and then I'm going to go check on him, is let's solve. Well, since we know that we can't factor it, and you've already got this piece of it, this is a great one for quadratic formula. So if we go x equals negative b plus or minus the square root of, bam, 28 right there, and then all over 2 times a, radical 28, that'll simplify down to 2 radical 7. And then you're dividing each piece by 2. So you would have 6 over 2 plus or minus 2 radical 7 over 2. So your answers here should be 3 and then plus or minus radical 7. So there's your real numbers, but that are irrational, and they would definitely be unequal. One's going to be plus, one's minus. All right. Go answer that post-video question, and I'll talk to you guys soon.